Hi, I'm Adam. Welcome back to Godot GameLab. This is 2D card fanning using Godot's built-in curve resource. You can see if I start drawing cards and discarding cards, the hand updates accordingly. If the cards don't fill up the whole hand, they are centered. However, if their combined size is bigger than the hand, they are dynamically crammed together so they don't overflow. If we take a look at our hand node here and go to the inspector panel, you can see that the distribution of Y position and rotation of the cards is provided by two curves you can edit anytime. You can also customize the maximum rotation in both directions, the default X separation, the starting Y value, and the Y offset value via export variables. There are two branches in the GitHub repo. If you want to follow along, download or clone the starter project branch. If you just want to see the end result in Godot or want to tinker with it, use the main branch. Downloading is simple. Click on the branch you want, go to code, and download zip. I have the starter project open in Godot. If we run this, you can see that the hand has a placeholder script because if I click on draw card, or discard card, we only get console messages that we should draw or discard a card. The game scene itself is simple. We have two color rects, one for the background and one for the hand. The hand is anchored to the bottom center of the screen and it also has a custom minimum size set. The game script is also pretty straightforward. We grab an already variable reference to the hand node and connect the three buttons pressed signals to callback methods. With the reset button, we reload the whole scene and the other two are used for drawing and discarding cards with the hand script. Now let's see the card scene. Go back to 2D view, press Ctrl-Shift-O and select card.tscn to quick open the scene. We have a panel node as a root node with a flat style box so it looks a bit more interesting. The only child node is a label for the card's name. The panel's size is set to a fixed size, in this case 100 by 140 pixels. I also changed the pivot offset for the rotation. See, if we reset to the default setting, that small cross snaps back to the top left corner. When we rotate the card like this, it looks weird, right? Because that will be the center point of the rotation. I recommend using the center point or the bottom center point of the card as the pivot offset. You can calculate the center point easily in the editor by typing the size of the panel, in this case 100, and dividing by 2 for both values. You can see that this cross snapped to the center of the card, and if I rotate now, it looks less weird. I'll just use the bottom center point as the pivot offset, which is at 50 and 140. Then the rotation looks like this. The card script is very basic. We have a constant for the size of the cards. This will be used by the hand script's calculations. We have an export variable for the text we want to display on the card and an onReady variable reference to the label node. In the ready method, we set the label's text property to this text variable. Now let's press Ctrl-Alt-O and quick open hand.gd. First, we load our card scene as a constant so we can instantiate cards from code when we click on the draw button. Then we have two export variables for the Y position and rotation distributions. We use the built-in curve resource for this. Finally, we also define 4 other export variables for customizing the display of cards. The first is the maximum rotation in degrees. Then we have the default separation of cards on the x-axis in pixels. Negative values mean the cards are crammed together. Positive values mean they have space between them. Ymin is the offset on the y-axis compared to the hand's position. This is applied to all cards regardless of the curves and calculations. Ymax is the maximum amount of y offset which can be applied to cards based on the hand curve. Both are given in pixels. We can implement drawing next. We instantiate a new card scene from the constant we loaded, then assign it to a variable. Then we set the text property so cards are properly numbered. getChildCount returns the current number of cards the hand has, and we just need to add 1 to it. Then we add that new scene as a child. Finally, we call updateCards, which is a method we are yet to implement. This is where the magic happens. Let's do discarding next. First, we do a safety check. If we don't have any children, we cannot discard anything, so we return from the function. Otherwise, we grab the last child using a -1 or -1 index and store it in a variable. We reparent it to the root node of the scene tree immediately and then delete it with q3. Finally, we call the magic update cards method to redistribute the remaining cards. Why do we need to reparent it before deleting with q3? q3 only deletes a node at the end of the frame when it's safe to do so. When we update the remaining cards, it could happen that the node is still queued for deletion when we redistribute the cards. That means it will still be taken into consideration as part of the hand. To avoid this, we reparent it immediately so we know for sure that when we call update cards, this card won't be a child of the hand anymore. Before doing the magic, let's use placeholder code for the update cards method. Save this with Ctrl S and let's run the game to see what we have. Drawing and discarding works perfectly fine, but the cards' position are absolutely off. But you see that we have our placeholder message here in the console that we should update card distribution every time we draw a card or discard one. This is perfectly fine, so now we can do the magic. So what are curve resources and how can we use them? Take this example. We have 3 cards equally distributed in the hand. We want the cards in the middle, or one card in this case, to be slightly elevated, while cards at the beginning and the end should remain in their original Y position. We can represent the hand's width on the x-axis. The beginning is 0.0, the middle is 0.5, and the end is 1.0. These are basically percentages if we multiply them by 100. The numbers describe how far we are from the beginning of the hand. Now, if we create a curve like this, we can represent the 3 cards on the x-axis with the same positions, 0%, 50%, and 100%. If we test them against this curve, we got another percentage, a floating point value between 0.0 and 1.0 from the y-axis. This tells us how much y elevation or offset we need to apply based on the card's position on the x-axis. For the first and last cards, that is 0.0, but for the middle card, it is 1.0, which means 0% and 100% elevation respectively. If we have 50 pixels maximum elevation, the result looks like this. The first and the last cards won't be elevated because you multiply with 0, but the middle card becomes fully elevated. A slightly different example. The curve begins and ends at 0.5 and peaks at 1.0 in the middle. Sampling the points one by one, we get these y offsets. At 0.0, we apply a 0.5 50% offset. At 0.5, we apply 1.0 100% offset. And at 1.0, we apply 0.5 a 50% offset. In practice, with a 50 pixel maximum Y offset value, the first and the last cards is offset by 50% equals 25 pixels, and the middle card is offset by 100% equals 50 pixels. This is pretty cool because we can easily distribute our cards equally regardless of the size of the hand and the number of cards. The curve takes care of smoothly applying the Y position and rotation offsets. When implemented properly, it is quick and easy to tweak the curves and export variables to get the look and feel you're looking for. Let's go back to 2D view and switch back to the game scene. Select the hand node and go to the Inspector tab. Click on the hand curves empty here on the arrow and select New Curve. Left click to edit this curve. Here we can use the left mouse button to add new points to the curve. So let's add one at the beginning, one in the middle, and one at the end. If you accidentally create too many points, you can right click on a point to delete it. So now we want something like this. Let's grab the middle point, press and hold Ctrl so it snaps to the grid better, and let's move it all the way up. So it's at 0.5 and at 1.0 on the top. For the other 2 points, make sure that they are all the way down to 0.0 and they are at 0 and 1 respectively on the x-axis. If you find it hard to edit the curve here, you can click on points and you can set these values manually. Also, if you're not happy with the angle, how this looks like, you can grab these little handles to edit the tangent or the degrees we have here. So for now, I'll just use something like this, somewhere around 80 degrees. If you want to, you can input these tangent values under the points to make sure that they match. So I'll just use 6 on both sides here. 6 and -6 for the other one. And you can see that the curve becomes really symmetrical. Okay, now that we're finished, we can click on this curve resource again to collapse it. And we want to do the same for the rotation curve. So let's click on this arrow again, create a new curve, click on the curve resource. But this time, before adding the points, let's set this minimum value property to -1. Why? Let's say that the maximum rotation is 10 degrees. We want the left side of the cards to be rotated by -10 degrees, so they are rotated to the left by the same amount. We want the middle cards to not be rotated at all. Finally, we want the right side of the cards to be rotated by +10 degrees, so they are rotated to the right. So we want the curve which goes from -1.0 to 0.0 to 1.0. So when we multiply the values with the maximum 10 degrees of rotation, it gives us the results we want for the rotations with the correct signs. So let's add the first point here, the second one around here, and the last one around here. So it should look like this. The top right point is at 1, 1. The middle one is at 0.5 and 0. And the first one is at 0 and -1. Again, if you want to, we can set the tangents or the angles for these curves. If we expand the points, we can use a value we like. I just use 6 for the first one and also 6 for the last one. So the curve looks like this, a bit smoother. But if you don't like it, you can edit this anytime. That's what's cool about this. If we're done, we can left click on the curve resource again to collapse it. Now open up the hand script and get cracking with the update card method. First, we grab the amount of cards we currently have and store it in a variable called cards. Then we calculate the total size these cards occupy in pixels. The calculation works like this. We take the constant width or x size of the cards and multiply it by the number of cards we have. But we also have to add space between the cards, which is set by the xsep export variable by default. We multiply this by cards -1 because there's always one less gap than the total amount of cards. Here we have 3 cards and 2 gaps, right? And after that, 2 things can happen. The cards either fit inside the hand, like in this case, or this combined size might overflow, meaning it is bigger than the size of the hand. Take this example. If we have 5 300 pixel wide cards and a 1400 pixel wide hand, they overflow, even if we use 0 for the x separation value. What can we do in this case? We cram them together by overriding the default xsep value. We use a formula which makes sure that the resulting combined size of the cards becomes equal to the hand's width. Note that we didn't shrink the cards, they are still 300 pixels wide, we just made them overlap a bit with a negative x separation value. So how do we handle this in code? We create a new variable called finalxsep, which takes the default x separation as a value. Then we use an if statement to check if we overflow the hand's width. If we do, we recalculate that final x separation value. Then we can be sure that the combined size of the cards is equal to the size of the hand, so we set it as well. But how does this formula work? We subtract the combined width of the cards from the hand's width. This tells us how many pixels are overflowing. Having a negative value is useful here because we want to bring them closer together, so this new final xsep value needs to be negative. When we have that result, we just need to divide it by cards -1 and we get that x separation we need to apply to cram them together. Again, we use cards -1 here because there's always one less gap than the total amount of cards. In this example, the hand's width is 1400 pixels. We subtract 300 pixels times 5 from it, then we divide it by 5 minus 1. Solving this gives us minus 100 pixels divided by 4 equals minus 25 pixels. If we use this as the new final xsep value with our original calculation just to check ourselves, we should get 1400 pixels. So 300 pixels times 5 plus minus 25 pixels times 4. Solving this gives us 1500 pixels minus 100 pixels, which is 1400 pixels. Perfect. So when we apply this, we get this result. See, we don't have to do this last calculation in code. I just wanted to show you that if this right here is correct, we always get the hand's width when we apply this to the original calculation, so we can just set the combined size to be equal to the hand's x width. Next, we calculate the offset. Why do we need this? Remember, we said that if the cards don't fill up the whole hand, they are always centered. That's why. Here's how this works. We subtract the combined width of the cards and gaps from the hand's width. This gets us the remaining space at the end of the hand. We divide this by 2 to make sure that an equal space is left on both sides. Then we move all the cards and gaps to the right by this half space and voila, the whole thing is centered. But won't this be a problem when the cards are overflown and crammed together? No, the offset will always be 0 here because the hand's width and the combined width are the same value in this case. With the offset done, we can create a loop from 0 to cards minus 1. First, we grab the current card child and store it in a variable. Then we sample the curve based on the position of the current card. Sampling the curve means grabbing the y-axis value based on the x position. Here's how it works. The first point is at 0.0. The value it takes from the y is also 0.0. The second point is at 0.5. The value it takes from the y is 1.0. The third point is at 1.0. The value it takes from the y is 0.0. So for the sample method, we pass the x position as a parameter. It returns the y-axis value of the curve at that given position. But what is that formula inside the parentheses? We said that we need to equally distribute the cards, right? We take the biggest value we can get, 1.0, and divide it by cards minus 1. This gives us the size of those equal spaces. If we have 3 cards, 1 divided by 2 is 0.5. We need to subtract 1 from the number of cards for the same reason we did with the x separations. If we have 3 points, there are 2 gaps between them. Now we just need to multiply the 0.5 by I, which is the index of the current card. The first card's position is 0.5 times 0, which is 0.0. The second is 0.5 times 1, which is 0.5. And the last is 0.5 times 2, which is 1.0. Let's see another example. We have 5 cards, 1 divided by 4 is 0.25. That checks out because we have 4 equal size gaps between 0.0 and 1.0. Again, we multiply by I as we loop through the cards. 0.25 times 0 is 0.0. 0.25 times 1 is 0.25. 0.25 times 2 is 0.5. 0.25 times 3 is 0.75. 0.25 times 4 is 1.0. We have 5 card positions equally distributed on the curve. Awesome, right? One tiny problem. When we only have 1 card, cards minus 1 becomes 0, and it's a bit funky to divide something with 0. In Godot, this does not yield a runtime error, but still the sampling won't work properly with the curve. We can just use an if statement and set those values manually. In this case, I won't apply any y offset or rotation if there's only 1 card. Finally, we set the position and the rotation for the current card. For the final x value, we need to multiply the card's width and the final x separation by I and add them together with the offset. For the final y value, we always apply the y min offset, which is an export variable. Then we apply the curve-based y offset. For this, we use the y max export variable and multiply it with the percentage we got from the curve. Then we set the card's position to a new vector 2 with those values. Finally, for the rotation, we multiply the max rotation degrees export variable with the rotation percentage we got from the second curve. And that's it. Save the script with Ctrl S and run the game. If I draw and discard cards, the hand updates accordingly. The cards are centered if they don't occupy the whole space, and if they would overflow, they are crammed together. Awesome. So make sure to play around with the export variables and curves to get the result and look and feel you're looking for. One extra little addition here. When we actually run the project, we get a warning message warning us for a narrowing conversion. It says that float is converted to int and loses precision. So if you click on this, you'll see that this is the line of code. And yes, that's true because we do a division which would result in a floating point value. See, the problem is when we create this final x subvariable, I use this colon equals, right? So this will have the same type as the x separation. And if we scroll all the way up, this x separation also uses this colon equals, and this is an integer value, right? So this will become an integer, And then when we create that final x separation, this becomes an integer too. It might be better to use a float for this, but it doesn't really matter. I just kind of wanted to address this because yes, you can use fractions of pixels for the positions, but how would that render on the screen for UI, right? So it's fine to leave this as an integer, but if you're bothered by warnings, you can actually change this to a float. It's just assigning this as a float variable. We just have to specifically say that this is a float variable or convert xsep to a float before assigning it. And with this change, if we run the project again, that warning message should disappear. So I just quickly wanted to point this out. If you don't like warning messages, you can get rid of this, right? That's it for this video. I'll see you in the next one. Bye-bye.